This week, I would like to start by exploring one more property about the for loop and while loop, which is their state condition, or their logical opposite, or logical negation, called the exit condition. You can think about stay as opposed to exit. They're completely the opposite concept to each other. Let's first of all review the syntax for the loops that we spoke about last week. So you can see the for loop, we actually got three parts separated by two semicolons, and the middle part SC. Standing for state condition. It can be any Boolean condition that will evaluate to either true or false. Similarly, for the while loop, there's only one part you have to specify, which will be just a Boolean condition as the state condition. We spoke about exactly how you can use the state condition as soon as as long as it evaluates to true, we're actually going to repeat for another iteration of the body of the loop. As soon as it evaluates to false, we're going to exit from the loop, right? That's exactly the two very important ideas about what state condition is. If you got any doubts, you can refer to the lecture notes or tutorial from last week. All right, so now let's do some little exercise over here. Let's assume we got two Boolean variables, P and Q, and P and Q can be storing any Boolean expression value, which will evaluate to either true or false. And we may use P and Q in the context of the state condition, either for a for loop or for the while loop. For now, I'm simply just going to focus on while loop, but you can definitely derive something identical to the for loop as well. Okay, let's now switch to the iPad over here. So we got two little exercises over here to warm up before we actually go on to see a slightly more practical example. The first one, we're trying to use P and Q in the case of conjunction. And let's see what the question is. When does the loop exit? And meaning that it's going to exit and stop repeating action number one. Action number one is the body of the loop, right? So we want to see that. So let's just use this opportunity over here to really review what the state condition is. So you can see P and Q over here is a conjunction, meaning that we are actually going to repeat action number one, which is the body of the loop, as long as P and Q evaluates to false. Evaluates to true, right? To true. As long as the state condition evaluates to true, we're gonna stay in the loop and then evaluate for and repeat for another iteration. All right. So this would mean, so what? When will we exit from the loop? So to exit from the loop. So exit from the loop, so that means stop repeating. Exit from the loop when it is not the case, right? There's a logical negation, exclamation mark. When it is not the case that we have to stay in the loop. And the condition to stay in the loop is simply this part here as we highlighted in green. So what would this be? Well, De Morgan, as we spoke about previously. So this will be simply not P or not Q. Thinking this way intuitively, in order to stay in the loop, P must be true and also Q must be true. That means if we are able to exit from the loop and stop executing action number one, so that means either P is false or Q is false. Either way, it's going to break the truthfulness for the state condition. All right, so that's a first warm-up exercise. What if we try to use, let's say, P or Q over here? Right, we're using disjunction. Again, let's now just clarify what does it really mean for us to really stay in the loop. So here we're going to repeat the body of the loop, which will be action number two over here. Repeat action two as long as P or Q evaluates to true. Right? You can see this part over here is really the same as the case for the conjunction, because they're both serving as the state condition. So what about exit over here? So we will exit from the loop when it is not the case that the state condition evaluated true. It is not the case that P or Q. So you can see over here we are simply putting a negation in front of the state condition here. So how do we evaluate this? Well, again, De Morgan is simply the De Morgan that we spoke about previously, about how to do De Morgan for disjunction. It will be in order to stay, we know that either P is true or Q is true. So now in order to exit, we have to make sure P is false and also Q is false. Both must be false. So that means P is not the case and also Q is not the case. All right. That's a very important warm-up exercise for you to make sure you understand what's going on over here. Whatever Boolean condition you specify over here, either this or this, I'm just using two specific examples over here. In order to figure out when the loop will actually exit, you have to take the logical negation of the state condition. That's the main lesson from this warm-up exercise over here. All right, let me switch back to the slides. That's exactly the two warm-up exercises I just did, and applying the De Morgan laws that we learned about previously. Let's now do one exercise for you. Okay, can you consider this loop over here? We simply read, assuming that input has been declared as a scanner, and then we simply read an integer from the user from the keyboard into variable x, and then we got this while loop over here. We say while it is the case that x is either larger than or equal to 10, or x is less than or equal to 20. All right, so that's the state condition over here. And of course, you can also figure out exactly what the corresponding exit condition is by taking the negation of the state condition, which is what we did in the warm-up exercise. And we may have some body of the loop. Let me just omit the detail for here. It's not important. However, I can tell you right away, the code over here compiles, but it has a logical error. But why? I would suggest you pause the video and try to analyze what the state and exit conditions are respectively, and then you will be able to answer this question over here. I would suggest you do this exercise here. All right, assuming that you already thought about this, let me now switch back to iPad and let's do this exercise together. I would say for this exercise over here, so there are two ways for you to solve it. Why don't we first of all focus on the state condition? It will be either this, or let me use another color, or this. In order to do the state condition, you can see here we actually got or disjunction by taking the union of the constraints. So let's now visualize this very quickly. If you still cannot see, let me just help you a little bit. The green one, x should be larger than or equal to 10 over here, and also the orange one, x should be less than or equal to 20 over here. And then are we taking the intersection or union? We are taking the intersection over here, right? So that means it's going to cover the entire number line, basically the entire one, from minus infinity to plus infinity conceptually. So this part over here is really equivalent to true, because any input value x is going to satisfy any point. Any value over there is going to satisfy either the orange or the green over here, right? You can think about for this particular part, any value in this particular range is going to satisfy both the orange and the green. And anyone that's less than the blue one here is going to satisfy the orange. And anyone that's going to be larger than the blue boundary over here is going to satisfy the green, right? It's easy to see. So we can conclude that this part over here is really equivalent to true. Okay, and now remember the very definition for the state condition. As long as this particular state condition evaluates to true, we're going to keep repeating the body of the loop, right? Now, true will always evaluate to true. Always evaluates to true, always. So that means never exit. It's a very important conclusion over here, just by looking at the state condition, meaning that you always stay in the loop, you will never exit. In that way, it's not good, because whenever you write a loop, you really want to patternize certain repetitions, but you don't really want to do it forever. You want to exit from the loop at some point, not really to stay in the loop forever. So this will be the first way to see this logical error, because you never exit. All right, so that's from the state conditions point of view. Let's now also try a second approach. How can we analyze the exit condition to reveal the logical error? It will be easy. You can see the state condition is simply the blue one I just boxed over here. So this is the state condition. What about the exit condition? Let me put it here. So the exit condition which I want to show to you would be not the case that 10 less than or equal to x, or x less than or equal to 20. Right? You can see this part over here is exactly put over here. Right? And then I will say not the case. That's when the state condition evaluates to false, and I'm going to exit from the loop. Let's now apply De Morgan very quickly. So this will just be equivalent to, so not the case, right? That's a logical law for the negation. So that will be 10 larger than x, right? You can see from less than or equal to larger than, and then from disjunction to conjunction, and also x larger than 20, right? You can see from less than or equal to larger than. So this will be the exit condition. Let me just highlight it in pink over here. So this is the exit condition. Can you see what the exit condition is? Well, let's try. Why don't we try something very similar? If you try over here, let's say this part here, let me just box it. Let's use green and also the orange over here. That's exactly what it will be. And then we are taking a conjunction because we're using we're taking the intersection because we're using the conjunction operator. The first one, x strictly less than 10 is like this. Strictly less than 10. You can think about this some exclusive bound over here. And also we got x larger than 20, which is going to be over here. And then we're saying that we're going to take the intersection. Do we have any intersection between the green and also the orange? The answer is no, we don't. So that's why this part is simply equivalent to false. And now this is not surprising because given that we knew before the state condition is actually true. So that means the exit condition is always its logical negation, which would be false, right? So what does it really mean when the exit condition is false? False simply means we also never exit. It's never an input value that's going to cause the loop to really exit. So that's why it's always false. So false always evaluates to false. It never evaluates to true. Okay, never exit. So that will give us the same conclusion. Okay, a final remark. For this particular example or many other similar examples, whenever you can draw such a conclusion that either your state condition is actually true or your exit condition is actually false, right? Either way, right? True and also false over here. So that simply means your loop will never terminate. So it's really like a so-called infinite loop. And this, in principle, is a very bad consequence of your program. So you really want to avoid from writing an infinite loop. And we're going to see a different example of infinite loop maybe later when we see more examples. But I would say from this particular exercise, try to really pay more attention to the kind of state condition or equivalently the exit condition that you're writing your loop for. In that case, you really want to avoid from anything that will never terminate. That's something you will definitely want to avoid.